Hello, and welcome to Summarize Science, where we break down cutting-edge research. Today, we're looking at a paper called ExpertFlow, a system designed to make massive AI models run much more efficiently. You see, today's large language models are so big that they can't fit all their knowledge into a computer's fast memory, the GPU, at once. To solve this, they use a clever architecture called Mixture of Experts, or MO for short. Think of it like having a huge library of specialized books. Instead of reading every book for every question, you only pull out the few relevant ones. However, fetching these expert books from the slow shelf to your fast desk takes time, and this delay can really slow the AI down. As you can see in these diagrams, previous methods were often inefficient. They would either fetch experts one by one, which is slow, or predict a fixed number of steps ahead, which is inflexible. What ExpertFlow introduces, shown in diagram D, is a dynamic approach. It intelligently decides how far into the future it needs to look to predict which experts will be needed, based on the task and the hardware. This diagram gives a simplified look at the ExpertFlow system architecture. Essentially, before a layer of the AI model runs, ExpertFlow predicts which experts will be needed several layers ahead. It then prefetches them, moving them from slow storage to the GPU's fast memory just in time for them to be used. It continuously learns and adjusts its predictions based on a feedback loop, making it incredibly adaptive. A huge part of this is smart memory management. Because the GPU's fast memory is so limited, you have to be clever about what you keep in it. ExpertFlow uses a two-level caching system, sort of like a VIP list for experts. Experts that are used frequently or are predicted to be needed soon are kept in the high-priority cache, ensuring they aren't evicted prematurely. This coordination between predicting the future and managing the present is what makes the system so powerful. And the results speak for themselves. These charts show the waiting latency, which is the time the AI model spends stalled, waiting for the right expert parameters to be loaded. The tall blue bars represent the baseline models, while the tiny orange bars are the same models running with ExpertFlow. In their tests across various models and hardware, the researchers saw an average latency reduction of 98.5%, and in some cases, it was over 99.9%. They basically eliminated the waiting time, making inference incredibly smooth. So let's quickly recap the main takeaways. Big AI models are often slowed down by the constant shuffling of experts between slow and fast memory. ExpertFlow solves this by creating an adaptive system that looks ahead, predicting which experts will be needed and preloading them just in time. This dynamic prefetching, combined with intelligent memory management, slashes the AI's waiting time by up to 99.9%. So, what could this mean for the future of AI? This level of efficiency makes it possible to run extremely large and powerful AI models on more constrained and less expensive hardware. It's a critical step toward making advanced AI more accessible, scalable, and sustainable for a wider range of applications. Ultimately, it helps bridge the gap between groundbreaking research and practical, real-world deployment. Thanks for joining us on Summarize Science.